Okay, so Recursion 2 builds upon the principles of Recursion 1, right? For the most part, everything that you guys did in the Recursion 1 workshop, we probably could have done with a while loop or with a for loop, um, conceptually. But there are some things that you can only use Recursion for, and usually those are things that are more undefined, as in you don't actually know how many times you may or may not need to do a particular process, or put it in terms of recursion speak, you don't know how many times the function might need to call itself. And one of the biggest, or one of the most common uses of recursion is to iterate through nested things, right? So if you remember when we talked about nested objects, really there's no limit to the amount of nesting something can have, right? It can be really it can approach infinite and is perfectly valid. However, if I was to give you an object or an array, for example, and I say, hey, can you give me every single number in this array? But I don't tell you how much nesting there is within this array. How would you be able to actually get through and make sure that you're checking everything to get to every number in the array? So that's like a very common problem, and you'll solve that for one of your workshop problems. But for now, at least, hopefully, we'll just kind of walk through a few examples together of how we would get there. So, for example, something like this crazy array variable, right? If you were to read it from humans visually, it can be okay. I guess it looks like there's 9 numbers there, but to a computer, each one of those arrays only has 2 things in it. The first one's a number, and the second one's a really nasty nested array. Easy way for a computer to read that, because you have to tell a computer, hey, go through this. Oh, but if this thing's an array, go through this. Oh, if this thing's an array, go through this over and over again, right? And even the way that we're talking about it just makes it sound like it's going to be a very tedious process if we have to do it manually. So this is kind of where recursion comes in handy, right? Because with recursion, at the end of the day, you're giving the base case, right? And so if you want if you want a function to go through something indefinitely, it'll be more than happy to, as long as you tell it when to stop. And in our case, we can really easily tell the stop to say, hey, if we get to a point in which we're only looking at numbers and not arrays, then we can probably stop, right? Otherwise, we need to kind of like inception, we need to go deeper into the array to figure out what the next level is. Okay. So in this case, if we have an array that just logs, if we try to have a function that logs out everything in a array, if the array is only 1 level deep, pretty easy, pretty happy, nothing special. But if we have an array that one of the elements is a nested array, well, it becomes a lot messier, right? Because the first thing is logs will still be a number, but the second thing it logs now, it will not be the numbers in the inner array. It will actually be the entire inner array. It will just be one thing. And the last the last asterisk on this page is saying, it'd be great if we had a function that could log out every number in an array. And that's the point. Right? We've already built this. So actually, we can just reuse this function over and over again. So in this case, for example, if I was to give you a function that says, logs an array, if I was to step through this, this is actually a really good example of where for loops and recursion, they don't have to live independently. It doesn't have to be like you can only use one or the other, right? This is a really good combination of the two. So I'll verbally describe this function, and then we can step through it as a group. Verbally, this function is trying to log out every number in an array, no matter how nested the array is, right? Obviously, one really big assumption we're making here is this array will only have 2 data types. It will either have numbers or it will have an array. Okay, so no objects, nothing else, only numbers and arrays. Okay? If I was to give this function an array, what this function will do is it will use a traditional for loop, right? It will iterate through every single element in the array, and then it will do a check. Okay, if the element is an array, we'll do something with the array. Otherwise, if the element is a number, we'll just print it out like we always have. Okay, so don't, so like lines, 1, 2, 3, 8, 9, and 10 are just what we were used to seeing with logging an array, right? It's just saying, hey, let's go through every element in the array, and if it's a number, let's log it out. However, if the element is an array, right? If array.isArray element, if this element is an array, well, let's just call ourselves again, except now we'll pass ourselves the element, which is an array, right? And our function is really well designed to take in an array and go through it on our behalf. So if I was to pass a function something like this, like an array with two elements, the first one is a number 1, and the second is an element of the second element is an array with 2, 3. When I go through this function, the first time it goes through it, it'll say, okay, great, you gave me an array, let me iterate through it, right? What's the first element? It's a 1, okay? Is it an array? No. Great, let's console log it out. All right, this is going really well. Second element, let's go through it. Is it an array? It is. Okay, great. Let's now add 1 to the call stack, or actually, yeah, I don't want to draw it out, but let's just add to the call stack, and we're going to call this logs and array function again, except now, what are we going to pass in as the argument? Okay.
Array 2, 3.
Right, the array 2, 3, right? This is the second element in this outer array, right? The first element with a 1, and we say, let's just log it out because it's not an array. The second element is the array 2, 3, and we say, oh, it is an array. So let's call ourselves and let's pass in the array of 2, 3, right? So when we go back to the top of our function, array is an array of 2, 3, and we then do this process all over. We say, all right, let's iterate through everything in this array. What's the first element in this new array? 2. And is that an array? No, it's a number. Great. Let's log it out. All right. Next thing in the array. What's the second element in the array? 3. Is that an array? No. Let's just log it out. And at that point, we're done with this function, right? We've iterated through every single thing in this 2, 3 array. We've reached the end of our function, and now we've actually finished the log array of 2, 3, right? And that also means that, well, once we finish the second element of this outer array, there's nothing else to do either, and so we're done as well. And in that way, what we've actually done is were able to log out 1 by going through the first element in the first array, and then we were able to log out 2 and 3 by going through each element in the inner array because we recursively called ourselves. Make sense? This shouldn't be that far of an extender from the problems you've been working on, but the difference, once again, between this problem and the ones that you did do in the morning section is just that in this case, we actually have no idea how deep this could possibly go, right? Like if this thing has nested arrays, 1,000 arrays deep, this will call 1,000 times. And to our, for us at least, we don't really care because we know we have a very confident base case of, hey, if something's not an array, stop. If it is an array, keep going, right? So that's just the main difference, is that now we're using recursion to solve problems for which we actually don't know what the final answer is going to be. So this is just an iteration through of this, okay? Similarly, if I was to give you an array and I want you to add everything together, okay. So in this function, what we're doing here is I'm feeding someone an array, and what I want to do is I want to basically combine all of these letters together, right? In this case, this is a very typical for loop, right? Nothing special. I give you an array, I create an empty string, I go through the array, and for each letter in the array, I add it to our string, and at the end of it, I return my string. By now, hopefully, this is super easy and straightforward for you to understand. But if I was to kind of throw this now into our old paradigm of, hey, rather than giving you an array of letters, I'm going to give you back an array of either letters or arrays of letters, or arrays of strings. And I actually don't know how nested the strings could be. Well, now we have a function that looks very, very remarkably similar to what we had before, right? In that we still pass an outer array, we still have our string, and we're still returning it. In the middle, we check this for each element in the string. If the element is not an array, aka if the element is a string, we just add it to our final string, exactly like we were doing before, right? Now the nuance is, hey, if something is an array, let's call ourselves on it. We'll pass ourselves the element that's an array, and that's going to return what? What is this going to return?
The first element is the next element of that array.
Not quite. So right now, if I run this array, right, if I run it on this particular input here, which is an array with two things. The first one's a string, the second one's an array. And the second array, there's two strings in there, B and C. The first time I run this, so the first time I run it for the first element, which is the letter A, I'll go through it, I'll say, great, it's not an array, it's just letter A. So final string becomes just a string with the letter A, right? When I run it on the second element, it's going to have an array, it's going to have two letters in it, B and C. Right? When I feed it through this, when I go through this for loop still to say, is this element an array? And the answer is yeah. So instead of using, I'm saying final string, which is now just my letter A, it's going to equal A plus whatever this returns. And what does this return? Well, if I feed this an array of B comma C, inside this loop, I'm recursively going to feed an array with two letters, B comma C, right? So this inner loop is going to have its own version of final string, right? And when it goes through the first element in the array, final string will just be B, right? And then when it goes through the second loop of this array, the letter will be C, and we'll add it to B, and at the end of it, we'll return the string BC. And so if this is BC and this is A, and we add them together now, when we return our final string, it will be ABC. This is definitely something that if you want to take some more time to look at on your own, copy the code and put it in a repo and add some console logs in there, you could. But this really is the fundamental principle of recursion, right? Which is this idea that I'm taking this really complicated problem, I'm breaking it into smaller pieces. In this case, the smaller pieces, hey, at any individual time, I'm just looking at one element at a time. If it's an array, I do this. If it's a string, I do this, right? And if there are other arrays inside those arrays, I'll treat all of those arrays as independent elements too. I'm looking at each independent thing one at a time. So this is just a variation of this. Okay. Oh, sorry. Yeah. So the next example is just that using the way we iterate through arrays. We can also do the same for objects too, right? By iterating through the keys and the values in a particular object. This example I'll probably spend a little less time on, and the reason why is just because I think it actually looks very similar to the array problem, except now instead of looking at each element, we're looking at each value. And once again, how do we get access to a value? If we have the object and we have the key, it's just the object bracket notation. You put the key in there, and that gives you the value. So in this case, once again, if I want to add up, if I have an object with two key value pairs, one's 10 and one's 20, well, if I want to use a normal for loop, pretty easy, right? I have a sum. I start at 0. I go through every value, right? I have access to every key, so through that I can get every value in the object. I add it to the sum, and I return sum. So that's our typical for loop example. But if I was to do it through recursion, in cases where for the values it could either be a number or it could be another nested objects, well, this at this point now should look very, very similar, right? Because this almost looks identical to the previous example, except now instead of checking whether or not something is an array, we check to see whether or not something is an object. And then rather than using a traditional for loop to go through an array, we use a for in loop to go through every single key value pair in the object. So same exact principles, but just a few syntax differences. Any questions? Right, and conceptually it kind of makes sense too, right? I still have my thing where it's like, hey, for every value in the object, if it's a number, I'll add it to my sum. If it's an object, I'll call myself a recurve to say, hey, here's a new object. Do you mind figuring out for me the sum of all the values, right? And so all I've really done in this case is I've built a function that does two things. One is it keeps track of a sum, and two is it's able to go through every value in an object, right? So whenever I encounter something that's a number, I use the sum functionality of it, and then whenever I encounter something that's an object, then I use the go through every single value in the object functionality of it. Sorry. Okay. So at a high level, that's the extent to which we'll cover recursion. Like I said before, some of the things we talked about there, some of